This question number 6.
Page
The question is the particle oscillates as per the equation x is equal to 7 cos 0.5 pi t meters. The time taken by the particle to move from mean position to the point 3.5 meter away is the time taken by the particle to move from mean position. Let's say this is mean position x is equal to 0, extreme position x is equal to a, x is equal to minus a. Time taken by the particle to move from mean position, not by, it is a plus a is minus a, extreme positions. Time taken to move from here to x is equal to 3.5 meter from mean position by 3.5 meters in here is how much? So what you have to understand here is x is, if it is, this is x, after what time it will be here is the question. Okay, so you have to say that as x is equal to this, to write 3.5 is equal to 7 into cos 0.5 by t. So 3.1s, 3.52s, 3.51s, 3.52s is 7. So you can write from this cos 0.5 by t is equal to 1 by 2. Got it? For what angle of cos to be 1 by 2 is 0.5 by t is equal to 60 degrees. Cos of theta is equal to this 2 comes here 1 by 2. So for cos of what angle is 1 by 2? 60 degrees or 5 by 3 radians. 5 by cancel. We get t is equal to 1 by 3 into 0.5. This can be expressed as 0.5 is 1 by 2 is 2 plus 2 by 2 by 3. So t is equal to 2 by 3 seconds. Okay. Which one? Which is option? 1 by 3 seconds. Sir.
that's all, sir.
Still, still going. No, no. You have to wind up.
8 o'clock.
So means the time taken by the particle to move from mean position to this. No, omega is 0.5 t, right? Omega is equal to 2 pi by t is equal to 0.5 t. So 0.5 pi, right? Pi cancel. from the second, right? This implies time period is equal to 2 by zero point 0.5 is equal to 4 seconds. Correct? 4 seconds. Now the question is, in 4 seconds, it will starting from mean position. In anywhere, if it starts from here, go to the extreme position, comes here, again go to here, then comes here, it takes 4 seconds. So that means it takes 1 second to go here, 2, 3, 4. But now the question here is, to be at 3.5 meter, how much time it is taking is, it takes, it is mentioned that, what is the amplitude? 7. Hmm? So in 1 second it can go from here to here to 7 centimeters. Means in 2 by 3 seconds it can cover what are the other possible 2 by 3 seconds also is given here, right? But what is the minimum time taken? Time taken by the particle to move from mean position to 3.5 meter away is, take from here, uh, uh, actually we have taken this is a cos function, right? Cos function means a time t equal to 0, that will be at extreme position. So x is equal to 3.5 centimeters means, the starting point will be this. Starting point will be this. From here, x gives x is equal to a, time t equal to 0. From here it decreases. From here it decreases. But if you want to take this, the time taken by the particle to move from mean position to this. So that means from here to here, somewhere here. From mean position means you have to take a sine function. Otherwise, to move from here to here, it will go, and again while moving here to here, it moves to move how much time it takes. So that here, what it tells us in this time, it moves from here to here. So the distance traveled to move from here to here, this point is 2 by 3 seconds, but not from mean position to this, from here to here. So in the other way, to travel from here to here, it takes 1 second, right? If you take this time taken from here to here is 1 minus 2 by 3, then that will be the corresponding time. So it is equal to 3 minus 2 is 1 by 3 seconds. Okay. So that you have to understand it before. Okay. Acceleration of a particle in SHM is 0.8 meter per second square. Then its displacement is 0.2 meters. Hmm? What is given here? T for main position is okay. 12th one. Right. The acceleration of a particle A is equal to 0.8 meter per second square. When its displacement is x is equal to 0.2 meters, the frequency of oscillation is f is equal to what? Okay. So how can you understand this? Acceleration is given irrespective of frequency. You know that acceleration A in terms of position is A is equal to omega square x. Okay. Uh, so from this you can say omega square is equal to the acceleration of a particle in the SHM is this, and its displacement is this. So omega square is equal to a by x. The acceleration corresponding to this displacement is given. So you can write it as 0.8 by 0.2 is equal to 8 by 2 is equal to 4. So omega is equal to 2. Omega is 2 pi. F is equal to 2. So 2 cancel. From this you can say F is equal to 1 by pi. Yes, 1 by pi h 23 h.
In all time, we should take omega pi t, sir. If they did not give, we should take omega pi t. Omega square means omega pi t, sir.
Omega square means
Omega pi.
omega is 2 pi f or
Okay.
2 pi by capital T. But we are asked different frequency, you have to take in terms of frequency.
That
Time
means
period
omega
means
square, sir. Frequency means omega square or not, sir?
omega is 2 pi times frequency.
Okay, sir.
Omega.
Okay,
Omega
sir.
square means this entire thing square root.
Okay, sir.
Okay?
Thank you. 14, sir.
Let us see here only the. So question number
14, sir.
electrostatics.
Yes, sir.
Electrostatics. 14 page number 36. The question is a uniformly charged thin spherical shell. Uniformly charged thin spherical shell of radius r carries uniform surface charge density sigma. Carries uniform surface charge density sigma. Its radius is r. It carries uniform surface charge density sigma per unit area. It is made of two hemispheres. This is one hemisphere. This is another hemisphere. Right?
Yes, sir.
From two hemispheres held together by pressing with a force of F. By pressing with force F. Right?
Yes, sir.
Then force is proportional to what is the force which is proportional to what? You have to understand here is if we have given this sorry is having surface charge density means there is a charge. So a surface charge density is charged by area. From this you can say that the corresponding charge is sigma into A. Now because of this here there will be a field E is equal to K Q by R square. Got it? And because of this field here and outside, a field is there. If you want to apply a force here and here, that force on this charge distribution, you have to apply the force of Q into E is equal to Q into E is KQ by R square. But Q square it becomes right K into Q square by R square. So here if you observe the options, if F proportional to if it is K, then you can write it as proportional to Q square by R square, but they have given in terms of epsilon and R. So we have to write it as 1 by 4 pi epsilon naught into Q in terms of sigma you want. So sigma square A square by 4 pi is there, right? Sigma square A square by R square. But A is not there in the options, so means you have to replace A. So all we will do is it is sigma square A square by 4 pi R square. You can take it as 4 pi R square. Is this A square? Q is sigma square A square.
Yes, sir.
Sigma square A square. Sigma A.
Yes,
So Q square means sigma square A square. 1 by 4 pi epsilon naught into R square becomes you can write it as epsilon naught into 4 pi R square. 4 pi R square is a surface area.
Okay, sir.
Surface area
4
then
pi r, sir. 4 pi r is surface area.
4 pi R square. 4 pi R square is surface area.
Okay.
Otherwise, can we write like this? This is equal to from this Q into, let us keep Q as it is. K is 1 by 4 pi epsilon naught into q by r square.
Yes, sir.
This q, let us write it as sigma into a.
Okay, sir.
Sigma into a. It is equal to sigma into a by epsilon naught into, this is
Uh,
what? R,
R
r or
square,
r
R
square.
square.
4 pi r square is a surface area.
Okay, sir.
A gets cancelled. So you can write this as, this is equal to q is there. Q into this. Q into sigma
By
by
epsilon.
epsilon naught. This is q again, if you replace with sigma a, sigma,
Yeah.
uh,
No, sir. Square root.
sigma q, write it as sigma a or sigma a. Okay. Sigma, okay, if you write it as sigma into this, here also you get only a,
It's
sigma
the
a
same
by
way.
this term only, right? It's sigma a by epsilon naught. But a is not there here. Sigma, oh, sigma into sigma becomes sigma square a by this. But a is not there. If you want to replace that, you have to write area. You can write it as sigma square into area will be 4 pi
4 pi R
r
square.
square by epsilon naught. 4 pi is a number. You can write this as sigma square r square by epsilon naught. 4 force is proportional to
Okay, sir.
sigma square r square by epsilon naught. But 4 pi you can take it as a constant, proportional
Yes,
to
sir.
constant. And you can write this way.
Yes, sir.
Hmm?
Yes, sir. Thank you, sir.
Yes.